Hello everyone. So let's talk about the radius of curvature of a projectile. Okay, so we learned the projectile motion and we are going to do what would be the radius of curvature of this projectile. So we know that, see, radius of curvature is a concept like already I explained in a way that you can solve it in two ways. Number one, you can go with R is equal to V square divided by AC, that which means radial acceleration. That's it. Or you can go with the radius of curvature, the mathematical formula 1 plus dy by dx the whole square, the whole raised to 3 by 2 divided by d square y by dx square. So in whichever way is like comfortable with you, you can go with that. But in this particular case, I would strongly recommend the first one, because the second one also you will get the answer, and you can find out, like it takes some time, more time it takes, so you don't attempt with that. Okay, so in order to prove it, or in order to just check with it, you can just do it. Okay, maybe we can also do it, but the thing is, like, you always go with the first method. So here, let's say at this point I want to get the radius of curvature. So what I'm going to do is, like, I'm just going to give that part alone. So here you can see at this point, what is the velocity? This is the velocity of the projectile at that moment. So what about the acceleration? We know that the acceleration g is acting downward, and let's say actually it makes an angle theta with the horizontal. Okay, the velocity is making at that moment. So you can see, I hope you're okay with it. So at this point, velocity is actually making an angle theta with the horizontal. Now I can, if this is theta, I can make two components for g actually. If that is theta, how much is this? 90 minus theta. So how much will be this? This is again theta. So then I can make two components of it. What is this? This is g cos theta, and this component will be g sin theta, right? So that will be, both of them will be perpendicular. So the components of g cos theta and g sin theta. So here it is very much clear that g cos theta is perpendicular to v. So what is g cos theta? This is what is fundamentally the radial acceleration. Here, the magnitude of radial acceleration. So what I want r is equal to v square divided by g cos theta. Okay, so this is the equation for radial acceleration, right? G cos theta is radial acceleration, and what is r, radius of curvature? V square divided by g cos theta. So now let me ask you a question. So like I'm going to make one problem here, that is, what is the radius of curvature at the maximum height? So here fundamentally g is actually acting downward, right? So what about this one? Velocity is in this direction. We already know that the velocity will be only u cos theta, because the vertical component of velocity will be 0 at the maximum height. So they are already perpendicular. So the radius of curvature, in the sense, this is the circle. This might be the circle over there, and the radius of that circle is basically radius of curvature at that point. So how to find out that? So at that moment, radius of curvature at maximum height is equal to u square cos square theta, because at that moment u cos theta is the velocity, square of it, u square cos square theta divided by g. You can see, right? Yes, this is the idea of it, and I hope you understood, and that's it. Or you can actually substitute there also. That's the idea. Okay, so that's it. So we will meet in the next video with some other problem. Okay, thank you.